So we're still in Unit 5, and what we're going to be doing today is comparing functions. All right, we'll be comparing functions. So today we're going to look at this example, all right? And we're just going to kind of go through this example, learn to compare these functions, all right? And these three different functions, if you notice, are in three forms. We have a graph, we have a function that's just an equation, and then we have our table. All right. So this is a good example because it's going to give us or actually show us how we can compare functions with the different methods. Okay. So first off, let's start by reading the question here. Three trains, A, B, and C, leave a train station at the same time. The graph shows a relationship between time and distance for train A. So this graph here is time and distance. Okay. So when we compare time and distance, all right, think about time and distance. Well, think about driving the car, miles per hour. Miles is your distance, hours is your time. There's time and distance. Okay, so basically this is saying after 1 hour, the train is here. After 2 hours, we're here. Okay, and so on. All right, so we're going to read this graph. So, number one, what is the rate of change of the graph? Rate of change. If you remember what we talked about Tuesday, we talked about slope intercept. Don't panic. I said you didn't have to memorize that yet. I just want to introduce you to it. Okay? But we talked about this m because this y represents f of x. And we said that m represented a slope, which was the change in y over the change in x. Okay? That's what we said. Look at this question. Rate of change. See the word change? The word change. Okay? So if I did change in y over change in x, my y-axis represents what? Miles. My x-axis represents hours. All right? So if I take this portion here, and I just write it right here, miles over hours. All right? Now, here's what's confusing. A lot of you are looking at this, you're saying, well, that's a fraction. I hate fractions. Don't look at it as a fraction. Okay? This fraction bar right here can represent a lot of things. It can represent a fraction. All right, we would say miles over hours. It could represent division, miles divided by hours. It can represent the word per, miles per hour. Okay, it can represent the word to. We're dealing with the ratio, miles to hours. We're comparing those. All right, so this bar can represent, right now we have represented four different things. That's why fractions can be confusing. But it's also a good thing because now you can look at this fraction as something different to make it not as scary for me. Maybe if I start looking at division, okay, fractions I don't like, division I don't mind. I can look at it as miles divided by hours, okay? But if I read this, I would say miles per hour, okay? So rate of change. What we're going to do now is we're going to fill this portion in with something from our graph. So what I'm going to do is I'm going to find a point on this graph that intersects at an exact point. For example, 0, 0. All right, that's an exact point. I know that, but I wouldn't use that because that's saying that, hey, we're going 0 miles per hour. Time hasn't passed. So if I go up here and look, I want to notice there's a point right here. All right, and that point on a coordinate grid would be 2, 60. All right, because let me erase my line here. This says they're counting by 40s every other line, which means the one in between 20, 40, 60, 80, 100, 120, 140, and so on. Okay? So now let's take this portion here, it's the x and y, and let's fill it in. So I filled in miles per hour. My miles is 60 miles in, oh, I wanted that to do that. 60 miles in how many hours? I look at my point again, in 2 hours. Can I reduce that? Yes. When I reduce that, it will give me 30 over 1. 30 miles per 1 hour. So the rate of change on the graph, the rate of change is 30 over 1, or you could say just 30 miles per hour. That's your rate. Okay, our rate, that's our speed. Well, we just answered question 2 and question 1. I got a little ahead of myself. What does this rate of change represent? Well, it represents speed. Okay, it's miles per hour. So it represents our speed there. Okay, so we're reading a graph here. All we've done is we broke down. We haven't really done anything too difficult. All right, I just broke down change. I said what my y-axis represented. I said what my x-axis represented. I just plug in information from the graph that I saw. All right. Number three, the relationship between time and distance for train B is given by the equation above, where x represents hours and y represents miles. Find the slope m. Notice this right here. What was that equation that I talked about a second ago? That equation was slope-intercept form. Y equals mx plus b. Okay, we're looking for m. Well, look in this equation. There's m. What is m? M is the number in front of x. If I take this equation, I write it right below it. And I can write plus 0 because there's nothing out here. We can add a plus 0. It doesn't change that equation at all. Okay, it stays the same. So y equals 45x plus 0. Remember, slope is m. M is whatever number's in front of x. What number's in front of x here? 45. So my slope here is 45. Okay, and now slope in number 1 represented miles per hour, which is 30. So 3, this would be 45 miles per hour. That's my slope. Okay, that's my rate of change. So if I were to graph that, I would go over 1, up 45, which would be probably about right there somewhere. Okay, so that line would probably move something like that. Which train is moving faster, train A or train B? We just answered that question. Train B. And why is train B running faster? Because it has a larger slope. Okay, with something like the slope is bigger. Okay, that's how we know train B is going faster, because 45 miles an hour is faster than 30 miles per hour. Number 5, the time distance relationship for train C is shown in the table above. What is the ratio of distance to time? Now, train C is a little harder to kind of break down because it's in a chart for us. All right. So now, if you think about what we did Tuesday, all right, we talked about changing y with changing x as our slope. Well, again, distance, if I go back to my chart, distance is my y. Okay, time is my x. So now I find my change in y over my change in x. From 105 to 210, it changes by, it adds 105. Again, adds 105 here, and it adds 105 here. Well, let's look at my time. This changes by 3, by 3, and by 3. So my change in y, I'll write that up here. Change in y over change in x. My change in y was 105. My change in x was positive 3. So what was my ratio? What was my slope? What was my rate of change? Notice I'm using 3 different terms, but they all mean the same thing. Okay? So if we understand our vocabulary in math, it can also make these a lot easier. Okay? Because ratio, distance to time. What was that? I said it could represent the word to. Distance to time. Okay? So 105 over 3, if I reduce that, that's going to give me 35. So that would be 35. I don't know what happened there. 35 over 1. That's what that would reduce to. Okay? We just divide both of those by 3. You get a 35 over 1. So my ratio would be 35 miles, because we have to write this as a ratio, to 1 hour. All right. Again, if this was K-Prep and you answered this as 35 miles per hour, this would be wrong, because it asked us for a ratio. It did not ask us for a speed. It didn't ask us for just the rate of change. So number 6 said compare the speed of train C to the speeds of A and B. Well, if we just compare them, I know that A is 30 miles per hour. B, that man is moving. He is 45. He ain't playing no games. He's trying to get you there ASAP. And C, He's just setting his cruise about 5 miles above the speed limit. He's just cruising through the day. So if we compared these, we would just know that train B is moving faster than the other two trains, and C is kind of middle of the road. All right, A is definitely the slower train. They did not put the turbo on that thing. Okay, so I know this is a lot going on. You look at this board, you're like, holy crap, what happened? But what we've done in this one example is we have learned how to compare three different functions based on the three methods that we talked about that functions are represented as. Okay, the graph, the equation, and the table. All right. If we can understand how to pull information from all three of these, it'll make this a lot easier. Okay. Again, I didn't do any crazy mathematical operations. I didn't throw anything crazy. All I did was I read this graph. Okay. So going back to this table, you might think, oh, change Y, change an X, or which one's X and which one's Y. Look at the graph. Okay. Distance is on my Y axis. Time is on my X axis. All right. So what we're doing is we're just visually looking, and we're using context clues. Okay, that's all we're doing here. All right.